So we have one more logarithmic equation to solve, and the point I want to get across with this one is that it's great to have a plan step by step for what you're going to do, but you have to learn to be flexible and start chopping away at things before you know the best way to solve them. So here I see that I've got a natural logarithm minus a natural logarithm equals another natural logarithm. So I can think about combining the two logarithms on the left-hand side together, and then I can use the one-to-one property to get rid of the logarithms essentially and solve from there. However, before I get started, I see a lot of ln's and e's together in that first term, and so I want to simplify that one first. And remember that the natural log of e to some power is just that power. So this first expression, I can replace that with just the exponent, natural log of x. So this is going to be a little simpler. The natural log of x minus the natural log of x minus 2 equals the natural log of 7. Now, my desire would be to combine the two logarithms on the left-hand side. Right? That would be my initial thought. Using this property, the natural log of a minus the natural log of b is the natural logarithm of a over b. However, there it goes by the magic of the iPad. However, that's going to lead me to an equation with a fraction, and I'd rather not solve a rational fraction equation if I can avoid it. So what I could do is I could add this natural logarithm to both sides. And what that's going to allow me to do is use this property, the natural logarithm of a plus the natural logarithm of b equals the natural logarithm of a times b. So I would rather use that one, but either way should work out. We get the natural log of x equals natural log of 7 plus the natural log of x minus 2. The right side becomes the natural logarithm of 7 times x minus 2, or the natural log of 7x minus 14. Now again, because we have one logarithm equal to another logarithm with the same base, their arguments must be equal, and that means that x has to be the same as 7x minus 14. Subtract over the 7x, subtract over the 7x to get negative 6x equals negative 14. Divide both sides by negative 6, and we get x equals 7/3 in lowest terms. Okay. May be helpful to know that that's 2 1/3, or about 2.33, when we go back to check it. So let me erase some of the marks that I made on the original equation. And I just have to make sure that all three arguments of the natural log are positive. And so, get the pen back. 7 is positive. That doesn't depend on x. That one's going to be good. X minus 2 is also going to be positive because 7/3 again is 2 1/3 minus 2. That's 1/3. That's positive. The first one, there's a lot of layers here, but if I put in 7/3 to this expression, and let me make this a little bigger, the natural log of 7/3 is okay because 7/3 is positive, and that result is also going to be positive. We're raising e to a positive number, that's positive, and then we've got the natural log of this positive number. And that's okay too. So the check is good, and 7/3 is our solution. Keep in mind that there's always more than one way to solve an equation, and I think the worst thing that you can do is set yourself up to where you only know one strategy and you have to stick to it. There are problems that you're going to make harder than they need to be. You need to be as agile and flexible as possible. Let agile be your adjective as a student. Right. In the next example, we'll actually solve a word problem.